Hello everybody. So I want to go over some of the released questions. I'm going to try to maybe guide you through it without actually telling you the answer. And then we'll go from there. Alright? So these are the sample questions. You know, you always have to do the sample questions to start with. The first thing a student should do if an accident happens during a science experiment. Okay? So the first thing you're going to want to do is let someone know. You're going to report to the teacher. A device used to determine the volume of a liquid. All right, anemometer is wind speed. You probably heard about those last year in 7th grade science. Graduated cylinder measures volume of a liquid. Test tube, basically just holds things. Thermometer measures temperature. All right. Which is a compound? Well, air is a mixture. Nitrogen is N2, or you might see it as N. Sugar is C6H12O6. And sodium is Na. Now, one of those is a compound. You have to figure out which one. Okay? This table provides information about some group 1 elements. So this is group 1. They've told us that. All right, we have elements. We have their melting point. Question says, which is the best estimate in the melting point of rubidium? Well, when we look at this from top to bottom, the melting point temperature is going down. So francium melts at 27 degrees Celsius. Lithium has to be 181 degrees Celsius to melt. Okay? So then what would be your best guess or prediction? That's what you're doing here. You're predicting the melting point of rubidium. Two different liquids are poured together in an open container. Bubbles begin to form. After the bubbling stops, it's determined the total weight of the two liquids is less than it was before the liquids were poured together. So what has happened? So imagine if you had two a container, and you have two liquids, okay, and you're going to pour those together, and they start bubbling. All right. Now, think of I know baking soda is not a vinegar, or is not a liquid, but think of baking soda and vinegar. Okay, you mix them together, they bubble, and gas is produced. That's what causes the bubbling. So as soon as you see this word bubbling, you should think two things: gas production and chemical reaction. Okay? And if a gas is produced, and that gas is maybe lighter than air, it would rise up out of the beaker. Okay? So, there you go. That's why if you want to actually test the law of conservation of matter, you always do it in a closed container. This is a chemical reaction. I'm on number 4 now. This is a chemical reaction for the decomposition of carbonic acid into water and carbon dioxide. So we have H2CO3 produces H2O plus CO2. Okay. How does the reaction support the law of conservation of mass? The important thing here is that as soon as you see law of conservation of mass, you should think balanced equation. Sorry, I think because I'm recording this, there's some lag in my writing. Balanced equation, you should think mass of products or reactants equals the mass of products. Okay? And then go from there. Now the same would be true for the numbers of atoms. So we have 2 hydrogen over here. We have 2 hydrogen. We have 1 carbon, 1 carbon. 3 oxygens, 1, 2, 3. So we have the same numbers of atoms on both sides, as well as the same kinds of atoms on both sides. Which best describes the method of obtaining energy that may cause changes in water temperature and harm to fish populations? So this one is weird to me. And I think installing solar panels on your home is not going to change the temperature of a lake or river. Hydroelectric power could affect fish, but it's not going to change the temperature. Okay? So that leaves A or B. And the better answer is A. And the reason I would say that is if we have a factory, right, and they're burning coal to make electricity, the way they do that is they burn the coal. The heat heats up water in some kind of container and turns the water into steam. The steam goes through a tube, turns a generator, and that makes electricity, right? And the electricity goes out to your home. Well, this hot steam has to go somewhere. It's going to condense, turn back into water, and some places may run that hot water into a lake by the factory or the plant. So I think that's why they're saying that. The water temperature, I think, is the clue there. Remember that oil, natural gas, and coal are fossil fuels, and they're non-renewable. Solar, wind, geothermal, solar, wind, that's a comma. Solar, wind, geothermal, hydroelectric, all of those are renewable. So these are renewable. These are non-renewable. How would a large increase in the salinity of an estuary most likely affect the ecosystem of the estuary? So remember, with an estuary, all right, here's North Carolina, and here's the barrier islands or the Outer Banks. Okay, so we have rivers that flow out to the mainland coast, and they carry fresh water, right? And that fresh water comes out into the bays or the sounds, but we also have Atlantic Ocean water coming in here. So that's an estuary, a place where salts and fresh water mix. So as soon as you see the word estuary, I want you to think salts and fresh. Okay? So what they're asking you is what would happen if for some reason you got more and more salt water in your estuary. Okay? You still got the same amount of fresh water coming in, but you got more and more salt water. Well, the salt water would kill the freshwater organisms, and so they would have the advantage at that point. Let's see here. Which would indicate the water in a lake is not safe for drinking. All right, so let's say you go and you collect some water samples. All right, now, if the water is really clear, it might be like that. Okay? And if it's a little turbid, it might be like that, a little hard to see through. If it's really turbid, it might be like that, really hard to see through. So turbidity, as soon as you see the word turbidity, I want you to think the cloudiness of the water. Okay? Cold water could still be contaminated, so no. Lots of oxygen in the water, it could still be contaminated. Lots of fish, it could still be contaminated. So high turbidity levels increase the likelihood that it could be contaminated. And certainly makes it more visibly likely. Geologist identifies the identical index fossil and rock layers from 2 different areas. Which conclusion is best supported? So what an index fossil does, okay, you have your rock layers. Here's my rock layers. Now some fossils, like the trilobite fossil, we find that thing throughout the fossil record. It lived, I believe, for a very long time. But then there might be other fossils that only lived during this time period. Okay? Now, if we go somewhere else, like maybe this is the US, and then we go over, I don't know, to China, and we go there, and we look at rock layers, all right, and we find that same fossil, that tells us that these 2 rock layers formed about the same time. Okay? And so that's why index fossils are important. They indicate that the rock layers must have formed during the same time because they have similar factors. Here's a real life example. All right? Let's say 10 years from now, you're scrolling through your old Instagram account, right? And you come across some pictures. Like a lot of the pictures are just you and your friends, and you're like, that could have been any time. But then you come across some pictures where you're wearing a face mask, and you're like, oh, that was during COVID. All right? You know that all the pictures where you're wearing a face mask were taken during COVID. So that's an index fossil of a picture. Okay? That's what they do. Number 10, which supports the theory that some mountains were once at the bottom of the ocean. Well, here's the thing. If you go up onto a mountain and you find like clamshells and stuff, that doesn't make sense. Unless either the mountain was underwater or the land was underwater and then it got pushed up and formed a mountain. So for example of this, we have the Eurasian plates and we have the Indian plates, and they are moving towards each other. And so some of the seabed got squashed up between these and pushed up and formed the Himalayan mountains. And so they have, these are the tallest mountains in the world, and then they have marine fossils at the top because they got pushed up by these 2 plates colliding with each other. All right, I'll move on. All right, so I'm at 15 minutes. I'm going to stop here, and then I'll do another video, like a part 2.